do Control-Shift+ to make this a bit bigger. And I'm also going to hit record because I totally forgot. Oh, somebody's already recording. Great. Never mind. Okay. So what's the first thing I do when I open up RStudio?
Are you looking for go into whatever assignment that we want to work on?
You're on the right track.
Just navigate to your project, right?
Project. That's the word I was hoping to hear. So open project. All right, and that's going to be in desktop. Data course Zon. Assignments. Assignment 3. Boom, there's an R project. Everyone have that?
Yep. I do.
Okay. Wait a few seconds. Okay.
I've got it.
All right, what is an R project? And why did we open that instead of just navigating to assignment 3?
So if we open it like that, it pretty much says, okay, everything you're working on is going to be relative from assignment 3, right?
Yes.
That's why we did it.
That honestly is like the only thing that an R project does for you, but it's massive, okay? So all of our code, anytime we point to a file, it's going to have the same path on all of our computers. All right. So now we're here in our project assignment 3, and we've got a few things over here on the lower right, an HTML and a PDF, an R script, an RMD. Don't worry about what that is. Our R project, that's the file we just opened. And then we had a little practice that we started last class period. I want assignment 3.r. If I just click on that, it'll open it up for me, top left. All right. So it's been a while, but Wednesday, this is what we were working through. Okay. So as we get more familiar with our code, I'm going to stop giving you pre-filled out scripts like this. And we're just going to be working with a blank script, all typing at the same time. I'm going to have you, when you hit a problem, share your screen with the rest of the class, okay, so we can work through stuff together. But for now, we're basically just working through this script that's going to kind of show us some functionality. If I want to run this line here, what do I do?
You can highlight it and then Control-Enter.
Control-Enter. As a matter of fact, I don't even have to highlight it. If I hit Control-Enter, it'll run that entire line all at once. Okay. Or I could go up here and push the Run button. But Control-Enter is way nicer. Okay. Okay, so 1 through 10 gives us a vector. What's its class?
Numeric.
Numeric. How do I find out what its class is if I don't know?
Class, parentheses, and then the object in question, so the 1 through 10.
Class 1 through 10. It better say, oh, it didn't say numeric, it said integer. Slightly different.
Because it's more than one number.
It's integer because it's just those whole numbers, 1, 2, 3. There's no decimals. Okay. And the way that R stores them, class 1, numeric. What? Class 1, capital L, integer. All right. So go ahead and try typing along with this. Class 1 tells me it's numeric. Class 1L tells me it's integer. R stores integers with an L after them for some arcane reason. I'm not really sure, but that means integer. what is class 333L going to give me?
Integer.
Better be. Yep, there it is. What about class 333.3L?
Numeric.
Error.
Error.
Yep, error.
Yeah. What it said was it's numeric, but be careful. So rather than error, it gave me a warning message.
It's probably called like a float or something. I remember all that stuff.
Right. In other languages, it's called a float or a double. In R, we just have numeric. Okay. The reason, like if you take a C++ programming class or something, there'll be a difference between something that has 8 decimal points or up to 16. The difference is one's called a float, one's called a double, and you can save space by using a float value if you don't need that kind of precision. R is designed around statistics and math from the ground up, and so they just gave it really big storage space for its numbers because we're looking for precision. This is a math statistics language, and so there's no difference between how many decimal points you've got. So R is designed to be really precise numerically. Okay. To make a vector, remember that is C for combine or concatenate. And then you just give it some stuff inside the parentheses, a bunch of commas. We can store things, remember, with our little arrow pointing to the left. That means we're assigning, all right? So we are assigning the value 1 through 10 to something called vector 1. If I hit Control Enter, what's going to happen? You can try it first.
Just gonna
It'll
repeat it
pop
back
up on
to you,
the right.
Pops up on the right, vector 1. So that's now just a variable name that we've got. In R, we call that an object. Okay. So we got a few. Remember, we can add vectors, divide, multiply them. But if it's a character class, like our letters here, vector 3, which is just A through Z, those don't have any numeric value. Okay, so we can't do standard math operations on them. Okay, so that's vectors. We've got another kind of object called a data frame. What's the difference?
The data frame is two-dimensional, right? Like an Excel file.
Two-dimensional. We've got rows and columns. Okay. So data iris, we can rename it, keeping the old one, assign iris to dat. And over here we see 150 observations. That's the number of rows. Rows are also called observations. And 5 variables or fields. Okay. So we can see what the names are. That's our column names, the names of our variables. We can see the dimensions, 150 and 5. That's rows, columns. And we can take a peek at it with head, just like in the command line. Okay. Data frames have a special little character. That's the $sign. So if you give the name of a data frame and then $sign, you can access columns by name. So I know I've got a column called species right there. So dat $species is just going to give me a list of 150 words. If I want to look at this, I can just go over to my object here and click on dat. If I click on the little arrow next to it, that shows me a little preview. If I click on dat itself, it pops up a new tab and kind of shows me just like we're in a spreadsheet, like Microsoft Excel or something, except you can't edit from here. And so dat $species is just that column. And what is the class of dat $species? Class dat. Ooh, data frame. Class dat $species. What's it going to be?
character?
Close. Special kind of character called a factor. Okay. We'll see these more in the future. A factor is a character class that's constrained to be one of only a few certain things. In this case, you can see we've got levels. That's your clue that you've got a factor as opposed to a character. That means if I tried to put a new species into this, it would say no. It would basically change it to NA, because the only things that are allowed to be in here are Setosa, versicolor, and virginica. Okay. Factors are kind of annoying, but be ready for them. All right. Now, this is the old school way of subsetting and accessing parts of a data frame. Okay. We use square brackets. We can do the same thing for a vector. If I say letters square bracket 5, what's that going to be?
The fifth row.
The fifth object in that list, right?
The
So
fifth,
A, B, C, D,
the fifth
E.
element in the vector called letters. So A, B, C, D, E. Boom, there's E. Does that make sense? The little square bracket access? Typically, it's used more commonly for vectors than for data frames because we have nice ways of dealing with data frames, okay, that are a little easier to read. Okay, if I wanted just the letters E and F, how would I get that?
So 5 and then comma 6 in those brackets.
So in the square brackets, 5 comma 6, it's going to give me an error.
Correct
That error
number of
is
dimensions.
incorrect number of dimensions.
Would you do put a C in front of it?
Mm-hmm. So we're actually giving it a vector. This gets kind of meta. We're going to give it the vector 5, 6. Right. If I just highlight C parentheses 5, 6 parentheses, hit enter, it's just showing me those two. It's a vector of length 2 containing the numbers 5 and 6. Now if I put that in square brackets with letters, that's E and F. If I say letters square brackets 1 through 10, what's that going to give me? First 10 letters. All right, let's get sneaky here. I want you to go ahead and type this, try it out. What do those two lines give me?
So you designated LET to be the vector 13579,
Mhm.
and then did you say, hey, let letters be abbreviated as LET? No. Oh, you said
As a matter of fact,
tell-
I made a mistake here. I used parentheses instead of square brackets. Okay.
Okay, so then it's going to tell you the letters of LET, but since you already designated it, it's going to tell you what the letters are of that group of numbers that you put in there, the 13579, right?
Yep, and that's ACEGI. All right. Does that make sense? We did something actually somewhat complicated here. We made ourselves a new vector of 1, 3, 5, 7, and 9. We stored that as an object called let, and then we used that object inside of square brackets to designate which parts of letters we wanted. Kind of a lot going on in those two simple lines. But if it's not making sense, please raise your hand, yell at me. I'll try to explain it better. Y'all good with this? Sweet. All right. For the first exam, we're sticking with basic plotting. Okay, we're going to learn how to make fancy pretty plots starting next week. Don't worry. But right now, we're just going to be using the built-in plot function. It makes really ugly plots. That's fine. It does it really fast. All right.
Quick question.
Yes.
Are we in week 3 or week 4 right now?
This is week 4.
Okay, week 4.
All right. So yeah, I should remind you, you do have an exam this week. It's already open. You'll have until Sunday night. Okay. And it's not going to be any more difficult than what we're doing today and Wednesday. Right. That's not to say it's going to be super easy for you because this is all still new, but you will have plenty of time. Okay. So now, if you do have questions, stop me. All right. So explain to me, somebody, in plain English, what this line is doing.
All right, I'll take a shot at it. I guess it's saying
All right.
assign variable x to be everything inside the column pedal length. That is also inside dat. So yes, inside dat pedal length, and assign all the y variables to be everything that's inside dat called sepal length, or inside that column.
Yeah, in that column. Yeah, so to be really precise, this entire line is saying I'm calling a function called plot. All right, that's built into R. And plot definitely wants x and y values because that's how you make plots. For the x values, those are going to be the column in dat called pedal.length. And for the y values that plot's going to use, I'm going to make those be the column in dat called sepal.length. If I hit Control Enter, boom, it gives us a nice little dot plot. Yeah, it's kind of ugly, but it lets us see our data really quickly. And so these kind of basic plotting functions can be pretty handy. All right, if you'll remember from last time, we did this second plot. Why is it different?
Because the y value has the data type of the x value has the data type of a factor, right?
Yeah. The plot function is going to pick the best plot it can for your data, just using a little algorithm based on what type of data you have and the size and the range of it. So it saw that first thing it does inside the plot function, it's called class on dat $species. And it sees that returns the value factor. And so it says, okay, well, our x-axis is going to be categories. It can't be numeric, so you can't have a dot plot. Okay, with categories, and then a y-axis is numeric. It makes the determination that the best plot for this is a box plot. Okay. Does anyone know what a box plot actually shows?
It shows the interquartile range,
Mm-hmm.
the middle 50% of the data or 25% of the data. I can't remember. 25% of the data.
25% of the data, and then the dark bar is the median. Okay. And then it will also show outliers if there are any. So it's not a bad call for plot to make. That gives us a nice little overview of what our data looks like. Okay. So we've covered the class. This is a really handy one. I estimate that 90% of all error messages you get in this course are going to be because you forgot a closed parentheses or a comma, and the other 10% are because you're trying to add, multiply, or divide a factor instead of a numeric. And so class is really handy for troubleshooting. All right, we've got str standing for structure. So we can look at the structure of that. It shows us a nice little simple output. It's saying, hey, here's a column in your data frame called sepal.length. It's numeric. Here's the first 10 or so values, just so you can see what's in there. You also got one called species. It's a factor with 3 different levels: setosa, versicolor, and ... I'm running out of room. Okay. Same thing you see up here. If you click on the little blue arrow, the little triangle. Okay. This is where we left off last class period. I'm gonna go ahead and run these 2 lines. I can just highlight both of them, hit Control Enter, and it'll run both. All right, so we made a new vector called nums. It is numeric according to class. How long is it? Without counting. Well, I can look over here on the right, and I see nums right there. It's numeric.
21.
1 through 21. Yep, those are the values. Okay. If I
just,
don't want to look over there, or if I want my code to figure it out for me, I can say length nums 21. Okay. If I just say plot nums, what kind of plot is that?
the best plot it can do.
It's the best, pretty much. It's one-dimensional data, and so you see the bottom here is called index. What's that mean?
It means it just arbitrarily send each one a number in order, just 1, 2, 3, 4. Yeah.
In order, yep. And so this is what that vector looks like in order. Okay, so there's 2 1s, yep. 4 2s, yep. So it's just kind of a nice little stepwise. I can say plot 1 through 1000. Oink. So it's doing its best. I can convert between data types. All right, so class nums is numeric, but I can say as factor nums. What's it done there? That as dot factor has coerced nums into a factor type of class. All right. So I can save that into a new object. My new object is called nums underscore factor. Notice how I don't have spaces in any object names. I'm going to assign to that the output of as factor nums. So there it turns up in my values over here, nums factor, factor with 9 levels. Okay. So let's see, we're going to plot nums, and then we're going to plot nums factor. Okay. Explain this plot to me.
Looks like it just did relative frequency of each number that occurred.
Yep. Notice that it's not treating them as numbers anymore, because plot nums will give me a nice little index. Plot nums factor, it says, oh, well, these are factors. The best plot I can make is to tell you how many of each one you have. And so that's what we're looking at there. Okay. All right. There's a few extra nice little things you can do to your plot. So I can say plot nums, comma, main equals my title, comma, x lab for x label, my axis label, comma, y lab equals my other axis label. So let's take a look at what features we can use with our plot by doing question mark plot. Question mark, the name of the function is your best friend. Okay, it brings up our help file. We can see what's going on here. Okay, it wants, these are the arguments. It wants an x, it wants a y, or arguments to be passed to methods such as graphical parameters. So we can tell it how big we want the plot to be. We can tell it where the plot points or lines or both. Okay. You want it to be overplotted. You want a histogram or high density. Okay. Then here's some other things. We can give it main, an overall title, sub, a subtitle, X label, Y label, and aspect ratio. We're doing asp. Okay. So if I do this line, it's the same plot. We plotted nums, but we also gave it some other stuff. So this is just like throwing extra flags onto a command line program. Same sort of deal. We're saying, hey, plot function, I want you to plot nums, but also main should be my title, my axis label, my other axis label. So main, your mom. All right. Anything we put in those parentheses, there it is. All right, so we can modify our plots that way, and we can also save them to a file. Okay. What good is the plot here in RStudio? For you, the researcher, it's handy because you can see your data and kind of like work on hypotheses and see what's going on. But you can't share that with somebody, right? You need that data file. The old school way of saving data files is to use JPEG. Okay, so question mark JPEG. Let's see, we can do a bitmap, a JPEG, a PNG, or a TIFF. Those are all image file types. Okay. It wants a file name. Then you can give it the width, the height, the units, that's pixels by default, point size, image quality, what color the background should be, resolution, and then this type is for like camera geeks and stuff. Okay. So how do we use this to save a file? Because this is kind of weird. It's a graphics device, and the help file isn't actually super handy. Could be better. If you go all the way to the bottom, it should give you some examples. So if I wanted to save this previous plot in my assignment 3 directory, what would I do according to the examples at the bottom here?
On your function call on line 121, plot, nums, etc., could you just assign that to a variable name called my plot?
Sadly, no. Well, it'll work. My plot. It's there, but it's empty. All it did was stick it up here. If I call it now, it doesn't do anything. It said that's null.
I mean,
If we look at our help example way down at the bottom here, it keeps going back up to me.
so that's saying, hey, this JPEG file that I want for the first line. Not sure what example, rect?
That's for any plot you've got. It's making a rectangle there.
Okay, so that's specifying, hey, I want it to be a rectangle.
Mm-hmm.
And then I don't think we've learned dev off.
No, we haven't. There's going to be a lot of things, I hate to say this, but it's actually unavoidable, that we don't explicitly teach in here, but I am dead set on teaching you how to figure them out. This is the first one. I'm actually going to explicitly teach this one to you, but I want to walk you through kind of the process of oh, how do I find this new function and kind of figure it out? I look at the example here. All right, it's saying I'm doing a PNG. Its file is called myplot.png. The background is going to be transparent. Plot 1 through 10. I'm adding a rectangle to my plot and then using dev off. All right, so I'm just going to try that. I'm going to take the little question mark out of JPEG here. And I'm going to put in quotes /, what's that mean?
In your current working directory.
Right here, which should be assignment 3. Example plot.png. Oh wait, JPEG. And then I'm going to copy that whole line right there, 121, stick it right there, and then move dev off up. Most people don't, once they start using other plotting packages, and we'll see those starting next week, they don't do this anymore because there's easier ways. But I want you to see this to kind of understand something about how R works, and because sometimes you'll find code that does use this. The JPEG opens a graphics device on your computer. Okay. So it just creates a link to a file, an empty one, named exampleplot.jpg, right where we are. Okay. Anything that you type after that, all your output will go to that file. Dev.off closes all links to files that you've got open. So the three of these together, if I hit Control Enter here, nothing happens. But in the background, it's now telling R, hey, if you see a plot, don't stick it up on the screen, send it to this file. Then I'm going to plot that. Notice that it did not show up down in my bottom right. It's not it didn't get sent to RStudio. Instead, it got sent to a file. So this is like the little redirect greater than symbol. Okay, we're redirecting the output of this to a file, and then dev-off says, all right, close that connection. We're good to go. So I want you to run those, and then look at your files and see if you've got exampleplot.jpg there. If you do not, we're going to get you to share your screen and see what's going on. All good? Did it work?
Hold on, still typing
Okay.
stuff.
Oh,
Yeah,
sorry.
typing away.
Don't forget about copy paste.
It worked.
All right.
Okay. All right, then where do we go to double check that?
Here we've got plots, packages, files. It should be right there.
I wish I had two monitors. This makes it a little bit harder.
Yeah. Another way would be to quickly
All right,
just
example
open up-
plot.jpg. We got
open
it.
up this, desktop, data course on, assignments, assignment 3, example plot.jpg. There it is. Double click it. There's your mom. Okay. So the JPEG function is always going to be basically the same. You give it the path to and name of the file, .jpg. You give it the plot function that you've gotten to work outside. So we kind of like built our little plot up here. Then we copy and paste it in there, and then we close with dev off. So that saves our plot to a file. All right.
Okay. What line is actually moving it over there? Is it the, because, yeah, that's, I'm confused about that. So we're saying, hey, JPEG, our working directory, and then the name of it,
Mhm.
plot, wouldn't that just say, hey, plot this? How did that move it over to, oh, we were already in, oh, that's what it's saying. We're already in assignments 3
Yeah,
because
yeah.
that's our working directory. Okay, so it just saved it straight to there.
Yeah.
We didn't send it anywhere.
No, we didn't send it in. We sent it to here. Yeah.
Okay.
So if
As a
I
matter of fact,
accidentally just did a dot and no slash, would that send it to root or something?
No. Watch this. If I do the dot, no slash, run those, it's not showing up here, but it is there. All right, let's see here.
Well, it turns into one of those hidden files, right?
It's hidden because it's got a dot in the
The
front.
dot in front of it.
There it is. Dot example plot.jpg. It's just hidden. That's kind of tricky situation. You could just say example plot 2 with no dot slash. And look, that's going to show up because it already knows where you are. What I like to do to keep my sanity is always the dot slash, which just reminds me, the human, that, hey, this is getting saved right where you are. Okay.
Okay, Ron.
Yes.
So it turns out that mine is still not showing the examples plot.jpg. Should I share my screen?
Yeah,
Or-
share your screen. I'm gonna turn off my sharing. Let's see what's going on with yours. Are you sharing? I can't see anything. Oh, there we go.
Okay.
Okay. Simple plot.jpg. All right, so run lines 148 through 150 in order.
Oh, okay.
Yeah, like, or yeah, just one at a time is okay. Try get WD, open close parentheses. Make sure we're in. Yeah. Ah, okay. So you're in data course Nunez, not, you're in the main project, not assignment 3 project.
Okay.
So let me reshare my screen. So when you do that, go open project. So you're in the main data course. Wait, I got too many of these. All right. So data course is on. You clicked on data course Nunez here. Today, actually, we're working inside of assignment 3.rproj. That should fix it for you. What you're gonna see is that in data course Nunez, you're gonna have a plot called example plot.jpg.
Okay. Yeah, thank you. Sorry, it's just that you cut out for a split second, and I think I missed that. I missed that part.
Okay, I'm getting some feedback here.
Okay.
There we go. Okay. So what he had accidentally done was,
Can you share your screen?
oh, sure can. I thought I was, I'm sorry. All right, that better?
Yep.
All right. So what he'd actually accidentally done was gone File, Open Project, and then to Data Course Nunez, and then clicked on that. So that's a main R project for the entire course. But today we were actually working within assignment 3, so I have to go to assignments, assignment 3, and then that project. And so his working directory was actually back here in Data Course Nunez, and I bet in there would be a file called example plot.jpg, because that's where it was saving it. I'm going to open back up. Come on, computer. There we go. Okay. All right, so Carlos, did you get that worked out?
Yeah, so just switch over to the other one and don't save
Switch
anything.
over to the assignment 3.rproj, and then you should be good to go. It was just saving it somewhere you weren't expecting it. So I'm going to copy the plot, put it there, take off the question mark, and then there I've got my 3 lines. So that's that should work.
Okay, thank you.
Yeah. Okay. So now let's just go ahead and run these next lines all together. We're making 3 vectors. One is character, one is numeric, one is factor. Okay. We can stick them together into a data frame manually like this by saying data frame, and then we're going to have a column called clothes, and we want that to be equal to col 1, hat, tie, shoes, bandana. We want a column called numbers. Don't forget the comma there. That should be col 2. Oops, there's my environment. Factor, numbers, col 3. Okay. So there's our data frame. By default, everything gets spit out to our console just like in command line. So if we want to save that, we can just go ahead and assign it. Equals also works as an assigner. I'm trying to get into the habit of just using the little arrow though. Right? So there's our same command from up here. We're just assigning that to df1. Okay, so now we've got df1 up here, 4 observations of 3 variables. We've just made ourselves a little data frame, 2-dimensional. Okay, so that's how you design a data frame from scratch. Typically, the workflow as data scientists or biologists, we're going to be importing like an Excel spreadsheet or something like that that's already got our data frame already there, but sometimes we need to make one. Okay. I want you to practice this real quick. I want the first 20 rows of iris that only has species and sepal length columns, and I want you to save that to an object called dat3. See if you can do this.
Sorry, could you repeat that one more time?
First 20 rows of iris, that's our data set. Okay. I want only these columns, species and sepal length, and just the first 20 rows.
Oh, it's right now, right there already. Okay.
So data iris, you should have that already. So I want just first 20 rows and just those 2 columns, species and sepal length. Let's take 5 minutes on this. Remember how we access 2-dimensional data. or how we subset it.
I was slightly zoned when you said what we actually had to make the columns. What were the two columns again? Sorry.
Oh, it's right there on line 132, species and sepal length.
All right, thank you.
Mm-hmm. All right, 1 minute remaining.
I'm pretty sure I got it.
All right, share your screen with us.
Quick question.
Yeah.
Is there a undo button to undo the
Control
last
Z.
Control Z? Okay.
Yeah, just like in Microsoft Word. Yeah.
So I'm using 2 different computers, but I can get it up on the second one really fast.
Or maybe you can just walk me through it and I'll do it here.
Okay. So I created a new variable called species, and then set that equal to C, so concatenating iris $ species.
Like that?
Like that, and then square brackets to indicate index 1 through 20 within that same.
Oh, up here?
Yeah, that's how I did it, at least. Within the parentheses, I think would need to happen. I don't know if mine's 100% right, but.
It's not. That's okay.
And
Let's
then
take a look at species. It's a bunch of number ones. It doesn't quite look right to me. That's okay.
Oh, so those are. Because that's data type factor, right?
Yeah, because it's data type factor. In the background, it stores them as numbers to save room, which is dumb. But
That is dumb. But it would work for the sepal length, right? You could do the same thing and then just, instead of $species, $sepal.length.
yeah, so sepal.length. We'll still call that species because it doesn't matter. And there we go. There's our first 20. Now, to remember, if we want some rows and some columns, since iris is two-dimensional, we have to give it two values separated by a comma, and it's rows, comma, columns, always in that order. And so we want to feed it 1 through 20 there, but then we want to tell it just the columns, species, and sepal length. So I could actually concatenate and say species, comma, sepal dot length. That's kind of confusing, but this entire little expression is saying just things that are in species and sepal length. Another way to do that would be sp for species, concatenate species, comma, sepal length. All right, so we got a new variable called spa, which is just species and sepal length. And then rows, we could say is concatenate 1 through 20. And then we could say iris, rows, comma, spa. Does that make sense?
Yeah, it does. Yeah.
Okay, this is
Hold up.
kind of tricksy.
Okay.
It's kind of tricksy to get your head around. I promise it becomes easier like once it clicks. So we could do it either of these ways, these 3 lines or this single line right here. I've just substituted this 1 through 20 to a separate variable, and I've substituted the concatenated species, comma, sepal length to a separate variable here. So there's our first 20 rows of just those 2 columns. We just want the first 5 rows. It's like that. So we tell it what rows we want and what columns we want. And so in this way, they don't have to be adjacent to each other. We can say we want rows 1, 3, and 5 by saying concatenate 1, comma, 3, comma, 5.
So for this, we didn't have to say data frame and then like copy and paste in the parentheses, all that, because I did that and I got the same exact thing.
Yeah, it's just a longer way of doing it.
Okay.
And on Wednesday, we're going to see a neat little shortcut because we're going to start using our first package called the Tidyverse. But this is very important to know. A lot of people, online resources will just teach R using the shortcut way, and then people get turned loose, and this kind of code still has to be used sometimes, and about half the code on Earth is written this way, and so you need to be able to figure out what's going on. This square brackets, rows, comma, species, or rows, columns, is widely used.
So all you did there was essentially shorten the longer code that you had above into that to make it more workable.
Yeah, what I don't like about this line I've got highlighted is that it's really hard for me to read. There's like commas all over the place. It's all one big long statement. You know, it's like a paragraph in Moby Dick that goes on for 3 pages. For me, this is a bit more understandable to break it up into 3 little chunks. First, I'm going to decide what species I want, then what rows I want, and then I'm going to say, okay, Iris, give me those rows and those species, or those columns, right?
Yeah. For line 142,
Yes.
Is the 1, 3, and 5 saying, hey, I want rows 1, 3, and 5? Well,
Yeah.
I might have missed that. Okay. So as opposed to for line 140, we're looking at 1 through 20.
Yes,
All right.
because that's what rows equals. All right, this is hard to read for me because like that is a statement. Here's the comma that's equivalent to this comma right there. So I'm saying, give me these rows, comma, oops, Control Z. Okay. And then give me these columns. And we can call them by name or we can call them by number if we know what those are. So names, iris, sepal length, sepal width, petal width, species. So I could say iris square brackets 1 through 5, whoops, through 5, those rows. And then if I wanted species and sepal length, that is number 5 and number 1. All right, here's our 5th column. There's our 1st column.
So you can pass it either the name of the column or the number.
Or the position of the column.
Gotcha.
Numerically. Yep. Best practice is the name. If a column has a name, why not use it? It's easier for you, the human, to read. If the column order changes for some reason, it won't mess up your code. It's still the same name no matter where it is. And so this is preferable to call them by their names.
So
What do you do differently again if you wanted just like, if you wanted rows 1 and 5 instead of 1 through 5?
Iris, square brackets. You have to do a little concatenate,
Okay.
1, 5. And then tell it what columns.
Mm-hmm.
Sure, column 1.
Okay.
Yep.
So maybe we went over this last time, I've forgotten, but have we talked about what the tab button does in R? Because I was trying to use it kind of the same as when we were doing Bash, where it would just fill in stuff. That
It will. It has a few functions. The first one is that it just gives you a tab while you're typing. The second one is anytime you type in 3 letters and it finds something that matches, you can tab complete, or it'll give you a little drop down so you can like look through it. So LET, it says, oh, are you trying to say letters or capital, all caps letters? And I can hit tab to autocomplete that.
Okay. The way I was trying to use it, and I don't know if there's another way to do it, is, for example, when we shortened species to SPP, we had already used it earlier, and so I was trying to do quotations, SP, and then tab, but that didn't work.
It won't do it in quotations because if you put anything in quotes, it thinks you're making a character string, and it does not presume to tell you what the next letter should be.
Okay.
If it's not in quotes, it gives you a list of things it knows about. So these are functions that start with SPE that it currently knows about. Or I could say, for example, call, and it's going to say, oh, do you want call 1, call 2, call 3? Another common use for tab is iris $, right? It'll give you, hey, here's the stuff I know about. That's the column names in iris. Which ones do you want? And that kind of helps keep you from misspelling things.
So how do we know when something will require quotation marks and when it won't?
The long answer is it comes with experience. But the rule of thumb is if you want it to be a literal string of letters and numbers and text that R doesn't know what it means, then put it in quotes. Right, so if I say ABC, it's just going to spit out ABC for me. Okay. If I say, in quotes, call 1, it's going to spit out call 1. But if I don't put it in quotes, it's going to give me hat, tie, shoes, bandana. Because not in quotes means look for this thing, and sure enough, it can find it. It's over here in my values. If I put something in quotes, it doesn't know what I'm saying. It just accepts it blindly as
Okay.
any text.
That makes sense.
Okay. Now the last thing I wanted to cover today was this function, write.csv. Okay. So if I do question mark on that, it's going to bring up the output. We're writing a file. Okay. So we've got our new little iris rose species that's just species and sepal length. I'm going to call that dat3. Okay. So now we have something called dat3. It's just a subset of iris. It's the first 20 rows, just those two columns, species and sepal length. Okay. Write CSV works like this. It wants you to tell it what to write, so the object. So that's dat3 in our case. And then in quotes, where to put it. So I'm going to put it in a right where I am called first file.csv. This one's pretty simple. There's some more stuff you can do. If I put here's another use for the tab. If I'm working inside of a function in the parentheses here and I'm like, what else can I do? I can put a comma and then hit tab and it'll show me the other things that I can add to this to change its behavior. Okay. And the way to see what those do is to let it sit on it for a second. It'll give you like a little list here, or you can go over to the help file. All right. In this case, no, it's fine. I'm not going to do anything else. Let's keep this one real simple.
Okay. I missed what you did with the dat3. Did you just assign the iris 120?
Oh, our new subset. Yeah.
Okay. And I got it. You just copy and pasted that over.
Yeah. And so then once I've got it assigned, as long as I've run these three, doink, now R knows about it, and so I can call it and say, hey, I don't want this to be an R anymore. I want to send it out to the real world, make a file out of this. So we made a subset of iris for whatever arcane reasons we have. Like we just want the first 20 rows and just these two columns. And now we're going to write that file out into the real world. And so that's where write CSV comes in. We say, here's the thing to write, typically a data frame, comma. Here's where to put it and what to call it. Put it here, call it your last name, first file.csv. Hit enter, and it should pop up for you. There's mine. Let me know if that worked out.
Let me take a look. I got to navigate over there. Yep.
Cool.
Any significance to what's CSV short for?
Comma separated values. It's pretty common. In bioinformatics and biology, most data is stored as CSV or TSV, which is tab separated. It's very uncommon to work with data in Excel itself for good reasons we'll get into.
There's no like push step that we have to do for this, is there?
Not yet. For assignment 3 there is.
Okay.
And that's down here at the bottom. So this is your remaining homework. I want you to do these tasks, okay? And then put it up on Canvas and GitHub so you just push this. So let's say I've just been noodling around in here, taking notes within this document. That's all great. But then I'll do this first one, plot x equals dat $ sepal length. Oh, I don't have dat, right? Dat is, I forgot I restarted. Dat is iris. Okay, plot dat sepal length. Y equals dat $ sepal width. Color equals dat $ species. I know that because I read the help file. Neato. All right, so I'm gonna copy and paste that into a file for Canvas or whatever, but I'm also gonna save it with Control S. And you can see this little asterisk up here in the tab. That'll go away when it's got all saved changes. Doink. Okay, Control S. So it's saved. And now I want to push it to GitHub. How do I do that?
Would it be found under Git on the top right?
Yeah, since we're in a project that is a Git repository, we've got a little tab called Git. This won't be there if you're not in a project and in GitHub, but we should be this whole class. There's Git. I'm going to go down and look for, there it is, assignment3.r. It's got a little M, meaning it's been modified. I click on that. That's like saying git add. Then I can click on commit. Brings this up. It shows me my changes. Oh, I made some changes there, added some things here, and then added my plot stuff down there. I'm going to give my message assignment 3 is finished, even though it's not, and click on commit. Okay. Close that, and then I've got a pull and a push button. I'm going to click push. It's going to ask for my username, gzon, and my password. Hit enter, and it says repository not found because I haven't set it up, but you will because you actually have your last name data course. I deleted mine for clarity. So that kind of simplifies your Git pushing a little bit now that you've got a little Git tab. You've got click on the things that you want to stage for commit, then click commit, give it a message, then click push, the green up arrow.
Okay, mine doesn't have the Git tab.
That must be because you are not in a Git repository and not in an R project that is a Git repository.
Okay, so how do I get to that point?
That's file, open project, right? Make sure that you get into assignment, your data course, and then assignment3.r project.
Okay, let me try that again here.
So desktop, data course, is this Lacey speaking?
Yeah.
Okay, so data course, Bowen, assignments, assignment 3, there's my R project. Once you're in there, then it'll ask you, do you want to save changes? Say, yeah, sure. Once you're in there, you should have your Git tab. If not, then you are doing something wrong or you don't have your data course Bowen set up as a Git repository that's linked online.
Okay. Could I maybe share my screen with you?
Yeah.
Just to walk me through that.
Mm-hmm.
Right. Let's just load in here.
This homework was due tonight, right?
Yeah, you should be able to finish it tonight.
All right.
Do you want both 3 and 4 tonight, or just 3?
Let's just do 3. Yeah.
Okay.
4, you can. I mean, you can go ahead and do 4. I think you've probably got the skills to do it at this point. You want to get it over with. It'll definitely help you understand class better on Wednesday if you've already tried to work through number 4.
Okay. But 3 is explicitly due tonight.
Yeah.
I have a question about the test.
Mm-hmm.
So is that listed on Canvas or on your?
It's on the course website. Let me share my screen real quick again. It's kind of at the very top of our course website page, right here, exams GitHub repository.
Okay.
See that?
Yeah.
So you click on that. It's got what's going to be covered on the exam. And there it is, exam 1. You'll probably want to copy this and do a git clone onto your own computer, so you'll just have easy access, and then you can just do git pull and get the exam file. But yeah, exam 1's already up. Here's the instructions, the grading breakdown, and it's got a couple of files that you'll need to do.
Okay.
Yeah. So we'll be using this extraction date file here. We're actually going to just make a couple plots from that and do some subsetting, and that's the exam.
Okay.
You
And
can
that's
get
something-
started on it now, and probably don't have enough practice with this until after Wednesday for you to probably feel comfortable doing the whole exam, but I bet you can get half of it done in the next 3 hours easily. Yeah.
And that's something you don't want us working with teams on, right? Just by ourselves?
You know, preferably by yourself. You're going to learn better that way, but if you are stuck, you can work together. It's fine.
Okay. Sorry, I know Lacey's trying to get her stuff going too. So.
Oh, no, you're good. I think it's not really letting me share it. I think because the recording is still going, potentially.
Okay. Do you still not have a Git tab?
Uh,
All right. So in that case, maybe you just got like a weird version of RStudio or something. Who knows? We'll have to meet one-on-one. Then
Okay.
you're just going to have to go into your command line and do git add dot set git commit m and do it the old school way. Okay.
all right.
It'll be fine. You'll
do you have
find
time right now to
when
do
we're
that with me,
working
or-
with like hundreds of files, this is way faster anyhow.
Okay.
What's that?
I was just gonna say, do you have time to do that right now with me, or sometime later this week, or?
Yeah, I've got 15, 20 minutes
Okay.
right now.
Just get
All
into
right.
a new little thing.
For people who have left and are watching this recording, or people who are still here, what I want you to do for Wednesday, where are we? Week 4. Okay. We're still actually kind of working on week 3 stuff. I want assignment 3 done. Okay. Start on assignment 4. It's actually not too different from assignment 3. It's just extra practice. And then do these practice business here. Make sure you read through resources before you come to class. It's going to really help you understand, and we can move faster that way. And then I want you to get started on this practice called logical operations. Okay. Just to get the feel for how we ask questions about our data. This is x greater or less than 9? Okay. And if x is 1 through 10, you get an idea of how this works. So get a feel for those, because we're going to be using them for subsetting on Wednesday. All right. And with that, I guess we can stop recording, and then I'll see if Lacey can get her screen to share.
Okay.
In the meantime, any other questions for accessing subsets of a data frame or doing a basic plot?
I'm sure I'll run into some when I
That's
start
fine.
doing the assignment.
Yeah, we are on the cusp of this getting really cool really fast. We're still paying taxes right now, learning how to like interact with R. By the end of next week, you'll be taking Iris and making beautiful plots with just a few lines of code. Basically an entire stats course you can cover with like 4 lines of code. So we're real close. All right, so data course Bowen, yeah, you don't have a Git tab. You're not in your desktop. You're in home data course Bowen.
Yeah, okay. I brought that up last time because I couldn't figure out how to get there to be.
Click on home there.
Okay.
Okay, now click on desktop. There, now click on Data Course Bowen. You've got two versions,
Okay.
and neither one is a Git repository. Okay, so, well, yeah, try assignment 3 there, and try clicking on R project. It's going to ask you if you want to save. Yeah, the .rproj.
Does it matter save or not here?
Go ahead and save. Oh wait, you don't have anything. Yeah. So
I just switched out.
okay, there's
Oh.
your Git tab.
What
Yep.
the?
You've got two versions of Data Course Bowen. One is in home and one is in home desktop.
Okay.
If I were you, I would delete the one that's in home
Uh-huh.
so you don't get confused.
Can I do that from here? Should I just do that in my Finder maybe?
Just do that in your Finder.
Okay. Just completely get rid of that. And then if I do this from home desktop, then my Git should be there.
Yeah,
Okay. Okay.
should be. If everything else fails, you're gonna have to kind of start over by going to your online version and like recloning that. Right?
Uh-huh.
Yeah.
Okay. So as
Just
of
make sure to
this,
clone it
though,
to your desktop, not to your home.
yeah. Okay. So if I just start with assignment 3, it'll be good for me to pretty much go through everything that we did again anyway. So if I just do that and do it through do it through the desktop, then Data Course Bowen, and the Git tab is still here, I should be good.
Should be. Yep.
Okay.
Yep.
That is good for me then.
Yeah, this happens. I've got like 4 versions of Data Course on my computer. I need to go clean them up also. It happens every time I teach how to like use Git and do Git clones. I wind up doing it to demonstrate and just sticking it somewhere else, and then forget to delete them. Yeah.
Doctor's on.
Like a ton of
Yes.
So I somewhat fixed the problem, but the thing was that my computer was slow. So then we kind of moved on, and I was like, okay, I'll just figure I'll leave it. Anyways, could I share my screen really quick?
Please do.
Yeah. So, I mean, I think maybe I'm just not looking at the right place, but so when I went to hello, can you hear me? Okay.
You're cutting
Yeah,
out.
sorry, it's just
Okay, there you go.
yeah, it freezes sometimes. So yeah, I went to the open project.
Okay.
Then go to this. Oh, yeah. Oh my god, I'm sorry. That like I said, this computer is a piece of trash. And desktop, and then this is the one that I'm using.
Yeah.
And okay, if it loads someday today.
It's trying to do a lot right now. It's fine.
And so like everything pops up. Oh come on. Okay, there you go.
Oh, yeah. And then assignment 3.
And then
Yeah.
and then open it. Yeah. So when it opens, like the console pops up, like over here, it's all good. It will be eventually, but then when I shrink the console so I can like find the code, you know, that you put there with the comments and everything, there's nothing there, and it has like an untitled page.
Oh, so our script that we're working with actually has to be opened. Our project doesn't know which R script you want to work with, so we have to actually open that. So as soon as this gets loaded, hit Control O for open, or you can go to File, Open.
File open.
Open file, yeah. Not project.
Oh, no, open file. Okay.
Yeah. So now we're in the project and we're going to open assignment3.r.
Simon, this one. Okay.
Yeah.
Yeah.
So this is the difference between the project and the script. The project is just letting RStudio know that we want to work out of this directory. Then you actually have to open, there it is, assignment 3.
Okay. All right.
And any changes you make to that, make sure to save them. So like your answers to the questions at the bottom, any notes you take, just hit Control S to save them, and that's good to go. And then you can push those to GitHub so you have them forever. And yep, there's your Git tab. Awesome.
Okay, perfect. Yeah, I mean, for the most part, I was following along, and then again, I still need to review it, go over it again. But yeah, thank you. Thank you.
Yeah. So if you have trouble finding it again in the future, let me know so we can stop and get you up on there. Especially because after the next couple weeks, probably, I'm not going to have very many pre-written scripts for you, and so being able to type as we go will be pretty important. All right, I'm out of here. I'll see you guys the next time. Practice, practice.
Well, yeah, for sure. Sorry, it's just that when I stopped sharing my screen, it died on me. Like I couldn't hear you. But yeah, I mean, definitely, I'll make sure to practice. So, thanks.
Hey, okay, did I cut off?
Yeah, but I kind of heard like to make sure to practice, and
Oh yeah,
for sure.
I just wanted to make sure that next time if you don't know what script we're working from, to stop me, because
Okay.
it'll be more important going forward because I won't have as many scripts that are pre-written for you to kind of like go back through. Here, starting in a week or two, we're going to be typing from scratch a lot, and so I want to make sure that everyone is kind of working together on that. So yeah, just let me know.
Oh yeah, thank you so much.
See ya.
Goodbye.